Hi everyone.
This is our Capstone project.
And we're Team F4. Recognize.
My name is Mary Day and I'm the hardware creator.
My name is Arya Paradkar and I'm the machine learning expert.
I'm Angelo Pagliuca, the web creator. We hope you enjoy our presentation. Just to introduce a little bit of our project, we will explain the basis to our solution we're trying to approach. Dementia, including Alzheimer's, is the sixth leading cause of death in the United States alone, where 16.1 million Americans provide 18.4 billion hours of unpaid care, with those hours valued at over $232 billion. So wouldn't it be nice to give as much help as possible to those in need of it? That's where RecognEyes come in. We made facial recognition glasses able to recognize and inform the wearer who their loved ones are around them. As a quick explanation of our overall project, I will take you through the block diagram of RecognEyes. The first thing the user must do is collect the data, in our case, around 10 to 15 pictures of each individual we want to recognize, later submitting this collection via our web application. Once the user enrolls their profile, we encode this data creating our model, which we then place automatically on the Raspberry Pi attached. On the hardware side of things, we have several connections to the Raspberry Pi. To the camera port on the Raspberry Pi, we have our flex cable and cable extenders connecting to the camera module on the glasses, so that we can take live pictures. On the speakers though, as you can see here, we were originally planning to have the audio jack connect to a newly designed amplifier connected to the Bona conducting transducer, but we were unable to complete this due to the project going virtual abruptly, and thus the audio jack now connects to an Altec speaker via aux cord, with our whole system being powered by a battery pack lasting about 6 hours. So now, let me take you on a tour around our web application. Here, we can see our homepage, where we have a quick introduction to our project, as well as links to take a deeper look at the development process. In fact, you can even see our final report by going to this link. We also have a section for introducing the creators of this project. This is just the three of us, as you can see here. While if we go a little bit lower, we also have the development block, where we kept all our weekly updates throughout the whole semester. And now, the most important part of the website, the device page, where we submit the data. In order to access this page, we first must create an account. So let's make an account, Team F4, with the username Team F4. Now, the only thing the user has to do is follow the instructions on the screen. So let me add myself to be recognized. I must first submit myself as a new person. So I'll start with a name, and then a relationship, which it could be anything, so why not just put web creator. Now that I'm added to this profiles database, I just gotta add my collection of pictures, and as long as they're less than 1 megabyte, they'll work. But for now, I'll just do one and pass it on to Arya.
I will now demonstrate how the website is linked to the facial recognition side of the project and go further in depth into what happens when we run our facial recognition algorithm. So here I will log into the website with our team account. The website is hosted on AWS. So we will see that Angelo, the web creator, has already been in here from the last time he registered. And we can add some more images of him as well. And let's go ahead and register the rest of our teammates. All right, and we will also upload some images for both of us. So you'll notice that in one image I'm sad, and another image I'm looking up and laughing. This goes to show that we need to upload diverse images in terms of emotion and orientation. Let's go ahead and add one of Mary as well. Now, normally we would be adding around 12 images per person or so to make our model robust enough, but just for demonstration purposes, we'll be adding 1 or 2 per person. So you will see that our watcher is already running. So when we press enroll, that should start the script automatically. And you'll see that it has started the script automatically. And when we train our script, this takes each image and uses HOG, or histogram of oriented gradients, to detect and crop around the face and convert this cropped image to a 128-dimensional vector. We store all of these vectors in a database. When a new image is taken for recognition from the camera on the Raspberry Pi, which Mary will show, it crops out the face and converts it to a vector and compares this new vector to our database of known encodings until it finds some close enough to say that it is that person. All right, enrollment is done. Thank you so much, and on to you, Mary.
Thank you, Aria. I will go through how the facial recognition script works in depth. In the Python script, we have a continuous loop that takes a picture, crops out the faces using HOG, as Aria mentioned, and converts these faces to 128-dimensional encoding vectors. It compares each of these vectors to the known encoding vectors that we saved during enrollment. It uses a support vector machine and a voting scheme to see which encodings our new vectors are most similar to. If it gets enough votes, the speaker will say that name in relationship. If it does not get enough votes on anyone, the speaker will say unknown. If there is no face recognized, the speaker will not say anything. This works with multiple people in view, and although the script is running continuously, it will only say one person's name a maximum of twice in 10 minutes. We wanted to measure our recognition accuracy of 95%, a false positive rate of 30%, and a false rejection rate of 15%, all running in under 3 seconds. We are proud to say we met all of these goals except for the time requirement. Our accuracy is 95%, our false positive rate is 28%, our false rejection rate is around 13%, and we perform recognition in under 6 seconds. We feel that this is acceptable since the user will probably be talking to someone for more than 6 seconds. I will now show this script running on my face, which is in the system. Here's the command to run the recognition file. So now I'm about to run the Python script on the Raspberry Pi. Here's my hardware setup. I have the Raspberry Pi connected to this external battery, the speaker, keyboard, mouse, and monitor for now, and also the pair of glasses with the camera on the left-hand side. So now I'm gonna point the camera facing my direction and hopefully you'll hear something. Mary Hardware Engineer. So in less than 6 seconds, you heard Mary Hardware Engineer, which is how I'm entered into the web app database. Once our team profile was enrolled, that created those encoding vectors, which was used to run this Python script. So now I'm going to detach some of the wires and make this a little more mobile. So now I can wear the pair of glasses, have the Raspberry Pi and the battery on my left hip, and the speaker by my right ear.
Thanks for listening.
Hit that like button.